we're going to find the two values of k such that y is equal to x raised to k, and it's a solution to the differential equation here. We know we need to take the derivative of y twice, so let's do that right now. Y prime is equal to, k is a constant, so let's bring that down. We'll have k, x. Now we don't know what k is, so we're just going to do k minus 1 up top. We need to find the second derivative, so that's going to be y prime is equal to, we'll have k being multiplied by k minus 1, and this is being multiplied by x raised to k minus 2. So let's start plugging this in. First, we are going to have that our x is equal, well actually not equal to, sorry, it's going to be multiplied. So we'll do x times k, and then we have k minus 1, and then we multiply this by x raised to k minus 2. And then we're going to do plus 3 times, we'll have our k here, we'll have x k minus 1 is equal to 0. I would love to factor out some things that are similar. First, note that this x right here is going to be able to combine with this x right here. And this is going to make it an x k minus 1. We can factor out two things. We can factor out a k, and we can factor out an x raised to k minus 1. So what's going to be left inside of here is just going to be, so if we look at this first one, we are going to have a k minus 1 inside of here, and then we'll have a plus 3 times k, and this is all equal to 0. So again, if you want to go a little bit slower, essentially what we did here is we simplified the solution to just be this part, and then we have, of course, all of this on the right. So we're factoring out everything that has to deal with this k x to the k minus 1. We're factoring this out, so we're factoring this k out, and then this k x, or x to k minus 1. So it all gets factored out, and so it's going to be left in here just k minus 1, and then plus the 3k. So now that we know that, we can simplify this even a little bit further. We'll have k, and then x k minus 1, and then we'll have our 2k, and then minus 1 is equal to 0. So how do we do this? Well, if we set k equal to 0, we can see that this is all going to become 0. So k is equal to 0. That's one of them. Now, let's look at this. Can we do anything with this one right here? Well, not really. We don't know what x is. We can't assume anything. So we're just going to leave this one and look at this next one. For this one, we just want this total to be 0. And to do that, we're just going to make k equal to 1/2. So those are the values for our k, to where this y is equal to k raised to, or x raised to k, is a solution to our differential equation.